All right, so let's talk about something wild that just came out of Google DeepMind. They just dropped a new AI system called Alpha Evolve. And no exaggeration here, it's actually evolving algorithms on its own. We're talking about an agent that doesn't just generate code like your typical LLM, it invents completely new algorithms that outperform human written ones. And it's already saving Google millions in computing resources. Yeah, this one's a big deal. So here's what's happening. Alpha Evolve combines Gemini's language models with an evolutionary system. Basically, it uses the creative strengths of LLMs to propose new solutions, and then runs these solutions through automated evaluators. The weak ones get tossed, the promising ones get refined, and this loop continues until the best possible algorithm emerges. Think survival of the fittest, but for code. And Google isn't just testing this in a lab. They've been running Alpha Evolve live across their infrastructure for over a year. It's already embedded in systems like Borg, which is Google's massive data center scheduling platform. Just from one of Alpha Evolve's algorithms, they've managed to recover an average of 0.7% of their global compute resources constantly. That might sound like a small number, but at Google scale, it's enormous. That's millions of dollars in efficiency gain. Now, what makes this even more insane is how Alpha Evolve approaches problems. Most traditional AI coding tools focus on writing short code snippets or patching small functions. Alpha Evolve, it's evolving full programs, hundreds of lines of code with deep, complex logical structures. We're way past autocomplete territory. This thing is designing actual computing infrastructure. One of the biggest highlights so far is what it did for Gemini itself. Alpha Evolve optimized a key kernel used in training Gemini models, specifically a matrix multiplication operation. That one change alone resulted in a 23% speed up in that operation. And because it's part of the core training pipeline, the overall training time dropped by 1%. 1% might not sound revolutionary, but when you're training these models across massive clusters for days or weeks, that's huge. That's time, money, and energy saved, and all of it came from AI optimizing the system that trains the AI itself. It didn't stop there, it also found a better configuration for an arithmetic circuit used in Google's custom tensor processing units, TPUs. Basically, it removed some unnecessary bits from a hardware design that was already highly optimized. The proposed change passed verification, got approved by engineers, and is now part of an upcoming TPU design. Think about that. An AI not only suggested changes to hardware-level code, it did it in Verilog, which is the actual language chip designers use. So yeah, we're in a new era now, AI and human engineers collaborating on the same technical level. What's also pretty cool is how human-friendly the results are. Alpha Evolve doesn't just spit out obscure, unreadable spaghetti code. The algorithms it discovers are clean, interpretable, and easy to debug or deploy. This makes it way easier for engineers to actually work with the results instead of spending weeks trying to decode what the AI meant. Now, here's where it gets even crazier. Alpha Evolve recently broke a mathematical record that stood for over 50 years. Back in 1969, mathematician Volker Strassen came up with an algorithm that could multiply two 4x4 matrices using 49 scalar multiplications. Nobody managed to beat that since, until Alpha Evolve came along. It found a new way to do it using only 48 scalar multiplications. That's the first time Strassen's record has been beaten for complex valued 4x4 matrices, a mathematical wall that stood for more than half a century, cracked by a Gemini-powered AI coding agent. This isn't just about beating records for fun either. Matrix multiplication is a fundamental operation in everything from computer graphics to machine learning. It's literally done trillions of times a day. So any improvement here, no matter how small, ripples across countless systems. Now, to be fair, Alpha Evolve didn't get this in one shot. For that 4x4 matrix problem, it generated and evaluated 16,000 different algorithm candidates. That's the beauty of it, though. It's not guessing randomly, it's applying evolutionary logic. Trying something, checking if it works, tweaking it, trying again, over and over until the best solution emerges. And if this reminds you of Alpha Tensor or Alpha Dev, That's not a coincidence. Those were earlier projects by DeepMind that also tried to improve basic computations. Alpha Tensor focused on matrix multiplication as well, but only with binary inputs. Alpha Dev optimized how computers perform operations like sorting and hashing. What AlphaVolve does is take things a step further. It generalizes the whole process. It's not built just for one type of problem. If the problem can be described in code and evaluated automatically, AlphaVolve can try to solve it. In fact, DeepMind tested it on over 50 different math problems, ranging from number theory to geometry to Fourier analysis. And get this, it matched the best known human-made solutions about 75% of the time. In around 20% of the problems, it actually improved upon those existing solutions. That includes the kissing number problem, an ancient geometric challenge dating back to Newton. The goal is to figure out how many spheres can simultaneously touch another central sphere without overlapping. In 11 dimensions, the previous record was 592. AlphaVolve found a new configuration that hit 593. One extra sphere might not sound groundbreaking, but in mathematical terms, that's a serious leap forward. All right, let's break it down in more detail how AlphaEvolve actually works behind the scenes. So the whole system is built around two main versions of Google's Gemini language model, Gemini Flash and Gemini Pro. Flash is the fast one, lightweight, super quick, and great for generating tons of ideas at scale. We're talking about producing thousands of code snippets in just minutes. It's the first line of attack when tackling a new problem. Then there's Gemini Pro, which is heavier and slower, but way more capable when it comes to depth, nuance, and making sense of more complex logic. Here's what usually happens. AlphaEvolve starts with a prompt. That prompt might include a full description of the problem, maybe some previous algorithms that didn't quite work, or just some hints about what kind of solution we're aiming for. Then it sends that prompt to Gemini Flash, which goes wild, generating hundreds or even thousands of small programs or algorithm variations. Sometimes up to 16,000 candidates for a single problem, like what they did with the matrix multiplication task. Now, each of those candidates gets evaluated automatically, and this is a key part. AlphaEvolve doesn't rely on human review to see what's working. It uses a set of custom evaluators, automated systems that look at stuff like execution time, memory usage, correctness, and whether it actually solves the problem. Every program gets scored based on these metrics. Let's say you've got a program that multiplies two matrices. The evaluator will check, does it give the right output? Does it do it faster than the current best method? Does it use fewer scalar multiplications? If it checks all the boxes, it gets a high score. If it fails or crashes, it gets dropped. Now here's where the evolution part kicks in. AlphaEvolve takes the best performing candidates, let's say the top 1%, and uses them as parents for the next generation. It feeds them back into the system, and Gemini Flash builds new variations based on those. The loop runs again. New code gets generated, tested, scored, and evolved. It's like natural selection, but for algorithms. And if things start stagnating, meaning the new generations aren't getting better, AlphaEvolve has a backup plan. It can throw in an old candidate from a previous round to shake things up and avoid getting stuck in a dead end. This prevents the model from overfitting to a bad solution path. If all else fails, that's when Gemini Pro steps in. Since it's more powerful and can reason through harder logic, it's used sparingly, like a specialist that comes in when Flash is out of ideas. Pro can add totally new strategies that Flash might miss, and once it generates something promising, the cycle continues again. This entire process can run through dozens or even hundreds of generations in a single run. And thanks to these automated evaluators, AlphaEvolve can handle problems where the feedback is instant and measurable, like performance benchmarks, energy usage, computation speed, or mathematical accuracy. The whole system is designed to work fast. What used to take expert engineers weeks of trial and error can now happen in just a few days of automated iteration. And unlike a human team, AlphaEvolve never gets tired, never loses focus, and can explore thousands of variations that most developers would never think to try. That's why it's not just generating code. It's actually discovering brand new algorithms that outperform decades-old human solutions. all by looping through this massive evolutionary cycle, scoring and selecting winners round after round until there's literally nothing left to improve. It's actually evolving the code, and all of this is happening in a closed feedback loop with automatic evaluation. That's key. The system needs to be able to verify each result immediately. That's why it works so well on problems with clear, objective metrics like data center efficiency or mathematical accuracy. And even though it's already making waves in data centers, chip design, and LLM training, that's just the beginning. Google says they're planning to expand AlphaEvolve into fields like material science, sustainability, and even drug discovery. Anywhere that involves algorithmic complexity and measurable results is on the table. DeepMind is currently developing a user interface with their People Plus AI research team, and there's going to be an early access program for academic researchers soon. They're also exploring how to make AlphaEvolve available more broadly in the future. Now, not everything is perfect. One limitation is that AlphaEvolve can't be used for problems where results need to be judged subjectively, like interpreting lab experiment results or creative writing tasks. It needs problems where solutions can be scored automatically. Also, while it produces these groundbreaking results, it doesn't always provide theoretical insight into how it got there. So if you're trying to deeply understand the why behind a solution, you might still be in the dark. But the practical impact is undeniable. It's reshaping how algorithm discovery happens. Instead of handcrafting solutions, researchers can now work with AI collaborators that bring a different kind of creativity, an exhaustively iterative, tireless form of exploration that humans simply can't match. So essentially, as language models evolve, AlphaEvolve grows stronger with them. And based on what we're already seeing, this thing's just getting started. If this is where AI coding agents are in mid-2025, the next couple of years are going to be very, very interesting. So now the big question, what happens when the smartest algorithms on the planet are no longer written by humans, but by machines evolving in silence? Make sure to like the video, subscribe if you haven't already, and let me know what you think down in the comments. Thanks for watching, and I'll see you in the next one.